with a binomial distribution question. So super important we have a good read through the question. I'm just going to do a bit of highlighting. Manufacturers found that the probability of the particular part in the mobile phone is faulty, so probability of faulty is 0.1. So that might be our success, right? So we'll transfer that down here. P equals 0.1. A batch of 30 phones arrived to be sold. 30 phones. Well, again, that sounds like an important piece of information. 30 phones. Okay, so it looks like we're testing a batch of 30 phones, so that'd be n equals 30, right? It doesn't say anything about taking phones out and replacing. I presume we say there's a big batch, like a big order of thousands and thousands. So we're going to assume, all right, that assume P remains constant. Now that'll be helpful, right, because we can then use the binomial distribution, right, binomcdf or CDF in our calculator, and we are going to just have this, oops, doesn't like me shading it in. This is obviously a fixed number of trials, right? So it feels like we're going well for a binomial question, right? So let's define our variable. Let x equal the number of faulty phones. Therefore, x can be modelled by a binomial distribution. We're taking 30 as our sample size and 0.1 as our success probability. And then all we have to do is now translate each of the worded questions, right? Each of the worded questions into a mathematical statement. The batch contains 8 faulty phones. So faulty phones is x, so this is x equals 8. But of course we've got to get the probability. So this is P of x equal 8. Now I'm going to write down all of the math symbols here first, then we'll get to our calculator. The number of faulty phones is at most 1. Okay, so this is about a language now. The most we can have in a batch is 1, so we could clearly have 1 or 0. So this is now probability that x is less than or equal to 1, which is 0 plus 1. And that might be a CDF, right? Over here, the number of working phones is between 8 and 15 inclusive. So 8, 9, 10, 11, 12, 13, 14, 15. So I think probability 8 less than or equal to x, right? We can have equal to 8, and we can have equal to 15. That's good. And finally, again, another careful reading of the question. There are at least. So the least amount is 25. So we want 25 or higher. So let's put that in. Probability x is greater than or equal to 25 equals. Right, now we've defined our model, we've defined our variable. It's very easy now to go and switch out to technology. So let's get the calculator open, and we are going to go for the first one, right? I think the first one you can clearly see is equal to, and then all of the others have some kind of inequality, so that's going to be a cumulative. So PDF and CDF, menu, probability, distribution, binomial PDF, number of trials 30, probability of success 0.1, and the specific x value we want is 8. There we go. So yeah, very small probability, which is I think what you'd expect, right? So I'm going to write this down to 3 sig figs, 0.00576. We should probably state 3 sig figs is the accuracy of the answer. And now part B, menu, probability, distributions, go all the way down, binomial CDF. This is cumulative distribution function. Again, 30, success 0.1, lower bound 0, and upper bound is 1, right? Off we go. And again, 3 sig fig, 0.184, Again, just write down the accuracy of your answer. Good communication. And now I'm actually not going to go through the long menu because I've already got binomcdf up on screen. So go up, up, enter, and just go back arrow, and just go ahead and edit the lower bound and the upper bound. So the lower bound is 8 now, right, and the upper bound is 15. Now binomial CDF is defaulted to include the lower and the upper boundary. To include the n numbers that you've put in. So it includes 8, includes 15. So again to 3 sig fig, 0.00778. Very small probability, right? Because if you think about it, the highest likelihood here out of 30 phones, 10% of them will be faulty, and 10% of 30 is 3. So you're going to get figures around about 3s, 4s, 2s, okay? So it's no surprise that anything, big like 8, 15 is going to be very, very small probability. And finally, let's go up, up, grab it, and now 25 and above. So the lower boundary 25, upper boundary is 30, right? Because there's 30 is the maximum number of faulty phones we might have, right? And that again, look at that, 0. It's almost impossible. Now the reason why it's 0 is because it's my calculator can only give me a certain amount of accuracy. Let's go see if I can change the accuracy. If I go to Documents, Settings, Document Settings, Float. I've got the maximum possible value of accuracy on here, right? Float 8, float 9, float 10, float 11, float 12. Let's go float 12. Let's go up, up, try it again. Look, it's saying 0. So this is 0.0000000. I mean, there might be some probability attached to it, but at least 12 significant figures and 12 decimal places, and the probability is actually 0. So for all intents and purposes, the probability of that happening is 0, which is an interesting result. I hope that helps. The only thing that you could actually add to this is some visual in terms of what does the kind of bar chart look like, the probability distribution function for a graph. What we could do is actually, I'll just do a little bit of extra for you here. If I go doc, insert a spreadsheet, what I'm going to put here is X. I'm going to put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. So just from the previous question. Now in here, this bar, I can put a little formula, equals, I'm going to put binomcdf. You see how I type it? It's in italics. As soon as I hit the F, boom, it becomes kind of straight. So now it understands that there's a built-in program I'm trying to go. Binomcdf, and what is it? It's 30, 0.1, x. So I'm going to ask in column B all the probabilities for the x values in column A. When I press enter, the question says, is X a column reference? Well, this is column A, B, C, D. And no, it's not. It's a variable reference because I've defined column A as variable X. And there you go. Look, you can see the probabilities of the highest probability is for 3 faulty phones in this batch, right? 0.23. And as we go further down, can you see, look, the probabilities start becoming tiny and tiny and tiny. So even for 10, look, the probability is minuscule. And then if I just keep going 11, 12, 13, 14, 15, right, look at that. The probability of having 15 faulty phones in a batch of 30 is already 3.2. Look down the bottom, 3.2 times 10 to the negative 8. So you can see why the idea of getting any kind of probabilities down here are minuscule. Hope that helps.